Hello everyone, welcome to a new video. In this video, we are going to cover the topic operating systems function input output. If you're new here, I would like you to subscribe to the channel, give it a like if you enjoy this content, and share this with your friends. Also, you get similar content from operating system lesson of NIOS senior secondary course in the playlist, and other subjects also get content from NIOS syllabus maths and English senior secondary course. Let's begin. What is input output? Usually input output is another function of your operating system. We have covered other operating system functions like process management, memory management and all. Here we are going to deal with input output. And what is input output? It refers to the communication between a computer system and the outside world. It involves transferring the data from and to the devices. So usually it involves reading from your hard drives, keyboards, USB. That is one kind of input, and writing to printer, displaying the information and network interfaces. All these things are there. So it is all like an input and the output kind of communication that happens between a computer system and the outside world. We call it as input output. Let's see in detail what it is. Let's see some examples of input output operation. So input output operation, usually reading of a file from hard drive, saving a document, printing a page, transferring data over a network, interacting using keyboard or a mouse. These operations can be input output. For your knowledge, these are the listed operations. Why do you think input output management is necessary in operating system? The reasons are input output devices usually operate very slower than your CPU. If it is not managed properly, what happens? It becomes, or it reduces your system's performance. To overcome this, your operating system uses the input output scheduling algorithms and a well-defined process for handling the input output operation. That means your operating system's function, one of the function is this input output scheduling, or it uses some algorithms, namely first come first serve, shortest seek time first. So these kind of algorithms are available which will help you to do this input output operations in a proper manner. So what this input output scheduling algorithm usually do? So they determine the order in which this input and output request has to be executed, which basically improves your system's performance. It helps to reduce the average waiting time of any of the process or the process that may be going on. Ensure fair access to the devices. So every process gets the devices on time. It is not stuck with one or two process. Everyone gets the proper usage time for execution or the resources they get. How these input output operations are performed? So input output request is initiated first. So a user or a program issues an input or an output request, that is opening a file or to print a document or saving a document. These all requests can be there. So the operating system sends this request to the appropriate device driver. The input output traffic controller. So what is input output traffic controller? This component that manages the flow of data between the CPU and the various peripheral devices are traffic controllers, input output traffic controllers. So what they do, they monitor the status of your input output devices, control units, communication channels, and it also ensures that the requested device is available and it is ready to be used for the process. This input output scheduler, what is this? This is the method used by your operating system to determine the order in which the input output requests are to be processed, especially to the devices like hard disk and all. So it is the method that determines the order of the request. So usually it considers the device availability, whether the devices are available for the request, that is input or output requests. Next is request priority, and based on what algorithm that priority is there, whether the process came first. If it is FCFS, first come first serve, based on the algorithms, fairness and efficiency. So every process is getting the resources on time, and some resources not using it for more time, and the other one is not getting. That fairness has to be met here. One is input output device handler. The operating system requires device driver software to interact with a particular hardware device. So it usually deals with the device specific operation and interrupts. Manages data transfer between your device and the memory and the device and the CPU. These to and fro the exchange of data happens. And it also uses the techniques like DMA, that is direct memory access, to offload the tasks from the CPU. So if you say what is DMA, DMA is the hardware feature that allows the devices, peripheral devices like your hard disk, your network cards and other graphic cards to transfer the data directly from and to the main memory without CPU being involved there. The process is completed. What happens is the operating system updates the process status. So it updates this information. It sends a notification or interrupt to the requesting program or user. So that notification will be sent, and then it frees the resource from the using tasks to the tasks that need them. So previously we have seen input output management, how it works for your operating system and how operating system helps in doing that. Now we are going to see file and disk management by your operating system. So if you see file management, what happens here? Operating system helps in storing the files on your hard drives, SSDs and USBs, organizes the file into the folders and subfolders, keeping track of the files which are saved, breaking the large files into small pieces, protecting your files and controlling who can access them, loads file quickly when needed, helps clean up and manage disk space. So this is about disk management. Lets you read, write, rename your files, and uses a tree-like structure to organize the file. So these are the file management that happens for your operating system, or operating system function is one among them. Next, disk management system in operating system we are going to see now, and it is controlling and coordinating the storage allocation and retrieval on disk drives, handling the disk formatting, partitioning and initialization. Next is managing the free space to keep track of used and available blocks in your disk, implementing disk scheduling algorithms, which we have talked about, FCFS, SSTF, SCAN, CSCAN, to optimize your performance. This CSCAN stands for circular scan. We'll see little bit of information about them. Talking about disk scheduling algorithms, so what usually is done, it prioritizes the disk input output request. It decides the order in which your disk head should move to serve the read or write request. So if you take FCFS, it decides which process is coming first. It has to be served first. That is the priority of your FCFS. Now you have SSTF. It stands for shortest seek time first. So what usually SSTF does is it picks the request that is closest to the current position of the disk head. While talking about disk head, what it is a tiny part inside your hard disk that reads data from and writes data into the disk surface. Okay, so usually it is located inside a hard disk drive. There are circular disks called platters. You can see the picture there. The platters spin very fast. Above each platter there is a small arm with a disk head at its top. You can see the picture here. Disk head hovers very close to the disk surface but does not touch it. You can see in the image. Scan moves the disk head in one direction to service all the requests until it reaches end of the disk, then reverses the direction and service request on the way back. So that is scan, and C scan also we have seen there. So it is circular scan. Okay. These are the different type of disk scheduling algorithm. You don't have to know much about it, but just have an idea what it does and how it works. Different scheduling algorithm works in different methods. It performs usually operating system. It performs the input output control for data transfer between the memory and the disk. When it comes to disk management, provides error detection and recovery mechanism for disk failures, ensures data consistency and prevents the corruption that is done that happens during read and write operations, supports buffering and caching to speed up disk access. Talking about the relationship between file and disk management, you usually have different levels where this file management is happening at the logical level and disk management happens at the physical level. The file system relies on the disk manager to store and retrieve data efficiently. Your operating system is interacting with your user, that type of interface we are going to see. So basically two types are there. One is GUI, or you can say graphical user interface. Another one is TUI, or command line interface. That means you have to give commands in the terminal. Usually example of this are DOS and Unix. If you have seen the screen, you will understand why we call it as command line interface. So basically a DOS screen looks like this, where you are going to type the command. Like this is a command, okay, dir. So you're able to see all the directories here. So this is a command line interface where you're typing the command in the terminal. For example is this Unix, where again you will be typing your commands. Talking about graphical user interface, it allows the user to interact with your operating system similar to your TUI. But the difference here is the visual elements like windows, icons, menus, and buttons are there instead of typing the command. You don't have to remember the commands and all the things. Here, everything is very visually properly arranged on the screen that you have to just select what you want, and all will directly properly to the information where you want to go. It is a very user-friendly and easy to navigate with a mouse or a touch screen. Example, if you say it would be Windows, Mac, operating system, Linux, but Linux with desktop environment like GNOME or KDE. So here differences between CLI and GUI is given, where one is command line interface, another one is graphical user interface. So here you can see the difference for each topic, like ease of use, which is more easy. GUI is always more easy because CLI you need to remember the commands, which is quite difficult for beginners. Those who are using it for the first time, it may look little difficult for them. Then speed, if you talk about the speed, GUI may be slower, and this command line may be faster for experienced user who already know those commands. Input methods are mouse, keyboard, touch screen, and all. Here you can use keyboard. Usually you will type using your keyboard the related commands. Examples are given here. This we have already seen. Next is in-text question 4.1. So let's see which are the questions. Choose the appropriate answer. What is an operating system? So four options are given to you. If you see one by one, collection of programs that manages the hardware and resource. Yes. System service provider to the application program. Yes. Link to interface the hardware and application program. Yes. So all the options are correct. So fourth one is the correct answer. D is the correct answer. Process. What is a process? So already we know process is a program in execution. So that is the second option. B. A blank is an intermediary between users and computer hardware. So which is that it's not operating environment, operating system in the blanks. So blank and blank are two types of user interface. So just now we have seen one is graphical user interface, another one is command line interface. Blank, blank, and blank are all the resources managed by operating system. So you have to write all the functions that you have learned till now. It can be memory management, process, input output, and file, disk management. All these are managed by your operating system. Blank is an example of GUI based operating system. So example of GUI is Windows. So hope the video was useful to you. If you liked this video, don't forget to give it a like. This video was useful to you. If you found this video useful, don't forget to give it a like, share this with your friends, and also write your feedback in the comment section. Thank you for watching. See you in the upcoming video.